Okay, so this is a nice collection of papers on critical and historical perspectives on usable climate science. So you can see that it's not useful but usable. It's a critical difference there. It was edited by Deborah Cohen, who is a historian of science, and Adam Sobel, who is at Columbia University, who's well-known climate scientist who has veered more into doing hurricanes, cyclones, climate and society kind of things. And his paper is what I'm going to use as an anchor, but will include some points from the other papers in this collection. There are a bunch of papers written by various climate scientists and social scientists, and I think an indigenous person of some sort who's also involved in, you know, community activity. I mean, whatever it is, right? It's getting different perspectives. Came out of two workshops, and here it is what Adam is saying. Usable climate science is adaptation science. The author argues that in the present historical moment, the only climate science that is truly usable is that which is oriented towards adaptation, because current policies and politics are so far from what could be needed to avert dangerous climate change that scientific uncertainty is not a limiting factor on mitigation. The author considers what implications this might have for climate science and climate scientists. There are many good points, and these are kind of discursive text material and not equations and figures. So I'm going to be brief, but main idea is that mitigation is, the main focus of all the events FCC UNFCCC negotiations, Paris Agreement, nationally determined contributions, and they have a mandate on national adaptation plans as well. But mitigation has emerged as a global concern, somewhat of a tunnel vision on carbon capture, etc., and of course renewables, EVs, all good things, but it is amenable to global leadership, and each country can submit an NDC and brag about how much they implemented in terms of renewable energy, EVs, etc. And adaptation, on the other hand, is local, hyperlocal. You heard me say all the time that we need hyperlocal risk information and early warnings, and of course there is another time scale for adaptation, which is, let's say, a decadal time scale, because decisions have to be made on dealing with climate change impacts that are already here or that are expected, in terms of adapting to them and building resilience. And my complaint has been that we keep worrying about 2100 with lots of papers, lot of resources into IPCC, and what good is it, who's going to use it, and have we already said all that is to be said about 2100 with all these scenarios which have evolved themselves over time. I have lots of podcasts on the IPCC process itself. So if we know that mitigation is pretty much now clear as a goal for climate action, adaptation is not getting as much attention. And for a country like India, I've spent last 6 years here, more than 6 years. There is a relatively small climate community which is growing very rapidly because there are many new climate departments, centers, etc. More and more PhDs produced, more and more faculty hired. Should they also keep focusing on publications, or should they worry about usable climate science? The issue, of course, is who defines usable. What is usable, for whom, and for what? If you are producing science to help with agriculture, water, energy, health, etc., that's one thing. But if you are producing usable climate science for geoengineering, is that the same? It can go in a very different direction, right? So, and a bank may use climate information, climate predictions, early warnings in a different way than a farmer or a fisherman and a government, and so on and so forth. So there are lots of normative questions, not just scientific and analytic questions involved. So let's see first what Adam has to say. I'll read random bits of the text just based on my own judgment about what is most salient in his arguments. I ask here to what extent and for what purpose climate science is usable. Okay, useful and usable are different. I define climate science for this purpose as science whose intent is to understand the climate system without trying to draw too precise a boundary around a set of people to whom my arguments and my use of the pronoun we apply. I certainly intend to include those like me, scientists who study the mechanisms at work in the atmosphere and oceans with some orientation towards the global scale, and who, if we were to participate in the Intergovernmental Panel on Climate Change IPCC, would be in Working Group 1, which addresses the physical science of climate change rather than social impacts, adaptation or vulnerability in Working Group 2 or mitigation in Working Group 3, and that's where I belong as well. I define usable science as science oriented towards decision making. The history and nuances of this concept are discussed by Deborah in another article, which I'll just not address here. So we always say policy relevant science decision support, but we are not always sure what it means in the end-to-end sense. While I intend the argument here to hold up to scholarly scrutiny, they are the outcome of personal reflection and of many conversations with the colleagues about the value of our work and our rationales for the choices we make, which applies to me and my journey as well. Some of us may wish to maximize or at least increase the contributions our research makes to the improvement of societal welfare, as some philanthropists wish to maximize the impacts of their financial contributions to saving or improving human lives. I take as axiomatic that usability in the sense defined above and discussed throughout this volume measures the degree to which a given piece of climate science contributes to societal welfare in a direct, causally discernible way. That's a tall order, but nonetheless, to ask to what extent climate science is usable is not to devalue basic curiosity-driven science. I neither assume nor argue that usable science is a priori the most valuable kind, nor is it to argue, even if we accept orientation towards societal benefit as the ultimate goal, that direct measurable causality is all that matters in assessing the contribution of any given piece of science towards that benefit. The full value of a piece of science, like that of a political action, can be fully measured in the moment, but cannot be fully measured in the moment, but may become clear only in a longer historical view. This is obvious. Basic research can be valuable and may add up with other basic research to something that materializes into societally beneficial outcome later on. Pretty much everything we use, wire, transistors to chips to software, everything, clothes, technology, everything accrues over time, right? So that's not the point. If we scientists wish to understand what value our work brings to the larger world, though thinking through our work's direct near-term societal consequences is a good place to start. Physical scientists are not well trained to do this kind of thinking, but the increasing urgency of the climate problem drives some of us to try. Our colleagues in the history, philosophy, and sociology of science are, on the other hand, trained to think about these kinds of problems. At the same time, they do not personally face the choice of what kind of climate science to do, or to take it further, whether to continue doing it at all, and so on. So people may quit and say, I will directly work on climate adaptation or climate action, climate communication, journalism, and so on. This essay expresses one climate scientist's attempt to put more conscious effort into thinking about how our work engages with the broader society, learning from the social scientists and humanists who focus on this problem from the outside, but not leaving the task of understanding it entirely to them. So just to put my own angle on it, I always did basic science as well, even though I was more in the process understanding of the OHC interactions, tropical processes in climate variability, ocean's role in climate variability, and so on. So process understanding can lead to predictive understanding and predictions, but more explicitly I got involved in predictions About 15 years ago, based on, because I got a nice project to do regional predictions, downscaling for, harmful algal blooms, fisheries, and I don't know. We did many things for air quality, agriculture, etc. And that kind of got me going on this in this direction, and now it's broadly called climate services and so on, which is more of what I'm doing. But my main interest is now early warnings for water, energy, health, infrastructure, agriculture, and so on. Does it mean everybody has to do it? Well, there is also the issue of worrying about what your job requires for promotions, for winning awards, whatever. So not every job allows you to go in random directions, even though many climate scientists manage to find time for what they call climate communication, talking to the media, writing in the media, and making talking to the general public and so on about the urgency of the climate problem and what we need to do, what government must do, how politicians are not listening to people, and so on. So if we are going in that direction and still doing only basic science, then maybe we are missing the point about the societal relevance of our own work as well, right? So what is Adam's answer? My primary claim is that at the present historical moment, climate science is only usable to the extent that it is oriented towards climate adaptation rather than towards climate mitigation, because climate mitigation is pretty much a technology solution now, and carbon capture and sequestration, all the EV and wind solution, solar and wind solutions, EVs, appliances, efficiencies, everything is going off towards mitigation, reducing emissions, decarbonizing, and so on. I hear some noise. It's coming from outside, so hopefully it's not spoiling my record. Introduction then, so this is the introduction to the issue itself, which defines a couple of more issues that I find interesting to include here. So I'm mixing different papers. Critical and historical perspectives on usable climate science is the special issue. The quest for usable science is shaping a new era of research into climate impacts and strategies of adaptation. Since roughly 2012, major international scientific research and assessment programs like the IPCC and the Future Earth have begun to insist on the necessity of incorporating the knowledge, experience, and values of users, stakeholders, and indigenous communities into the process of producing knowledge about the impacts of anthropogenic climate change. Impacts means then you help them with adaptation as well. On smaller scales as well, for instance, in the provision of regional climate services, efforts are multiplying to bridge the usability gap by making science more responsive to the needs of citizens. Could be dealing with extreme events or climate hazards on a daily time scale or seasonal time scale climate services. And then you have adaptation science, which, as I said, is planning for longer horizons. The descriptor usable has been applied to climate research conducted under the banners of post-normal science, citizen science, sustainability science, and community-based participatory research. It's often associated with research programs tailored to users' needs, such as climate services or attribution studies designed for legal applications, so liability issues there, so-called tort cases. These initiatives tend to be consciously interdisciplinary between the natural and social sciences, but they have been less engaged with humanities and with activists outside the academy. Well, there is much to admire about these initiatives. They raise pressing questions about the epistemic standards, knowledge creation standards, scientific ethics, and social justice that have not been adequately examined and that would benefit from sustained transdisciplinary analysis. So equity and justice, and who uses the information we generate and how, whether that can be used to standardize and centralize things that make life more miserable for some people, let's say poor people and so on, can be serious issue. So just because we make predictions and put it on the web doesn't mean it's going to help everybody. It can be misused as well, right? Collectively, these essays, so jumping to the conclusion part of that editorial, there is usually an introduction section to a special issue, and here it's by Deborah Cohen and Adam Sobel. So the last paragraph of this introduction says, collectively, these essays address the questions of who benefits from science and how science influences action for scientists and their partners, users, stakeholders, colleagues, and communities. There are multiple paths, multiple processes by which to pursue the goals that, despite our disagreements, our group of authors shares: effective, just, democratic, and equitable mitigation of and adaptation to climate change. So mitigation is not always completely separable from adaptation anyway. And there is one paper here on how we still need usable mitigation science as well. Okay, the essential ingredients are research defined by clear intention setting to support these goals, a dose of realism informed by history and evidence regarding the mechanisms by which it will do so, and engagement with those to whom the outcomes actually matter, so that you are not just creating these in a vacuum and putting it out, but the people who will get affected are actually co-producing with you, because adaptation is always some kind of an intervention. We have to remember that, okay? It affects people's lives, livelihoods, and so on. Good intentions notwithstanding, these ingredients are by no means universally present in the climate science of today, let alone the larger world in which climate change is debated. We hope this collection contributes usefully or usably to moving them to the center of the conversation. Coming back to Adam's article again, he touches on history, but there is a history article by Cohen as well in this collection. In the early post-war period, it was defensible for scientists and policymakers to see the climate problem as one requiring more research first and foremost. Climate science's capabilities then were modest compared to today's, and it could be reasonably argued that better understanding of the problem had to precede potentially costly mitigation actions. At the same time, there was a broad expectation justified by the burst of environmental legislation and institution building in the 1970s and 80s, including the signing of the Montreal Protocol and the formation of the IPCC, that advances in scientific understanding would influence policy in a relatively straightforward and non-partisan way. So this is considered a linear model where you do good science, and the policy makers, whoever they are, decision makers, whoever they are, notice your work, assimilate into decision making, so you are not worried about politics, governance, protests, activism, and so on. You just do your good science, gets taken up into policy and decision, and then they ask for better science or more input from you, and so on. So it's considered a linear theory, but obviously that's not how the real world works. But coming back to India, India can also think that maybe we are growing in climate science now, and we have to spend a lot of time on the basics of the monsoon, which is largely our focus, our monsoon in the global context, and work on basic science of that. But India is also experiencing serious climate impacts already. So it's not the future. Future is already here. So who then worries about doing usable science in a country like India? Works for all global south countries as well. And you can see whether China is doing better than India in incentivizing usable science, teamwork, and so on. I've written a little bit in the media about these issues as well. But the way IPCC thinking has gone, historical CO2 emissions before 2017 coming up to here when the data was taken for this paper, and hypothetical future emissions based on where you want to go. So if you want to go to 2 degrees C, you would come down this way, but if you wanted to do 1.5 degrees C above pre-industrial levels, then you will have to crash much faster in terms of bending the curve. These come from the so-called, we are moving the timeline. CO2 emissions decline from 2020 to reach net zero in 2055, which gives us more time to bend the curve and hit zero. Whereas if you want to do it earlier at 2040, you will have to do it much faster and that's the same 1.5 degrees C global warming target, 67% probability by 2100 and so on. Integrated assessment models do climate representation, but mostly are socioeconomic models, and they produce emissions scenarios which can be then fed to a system models to produce climate. There can be integration, but in general in the IPCC process, integrated assessment models guide the future pathways, shared socioeconomic pathways, representative concentration pathways, and all those good things. So what does this mean in the real world in terms of what climate science is needed? So all this debate about usable science, is this really news to scientists? To say that climate mitigation is currently a political rather than a scientific problem may seem obvious. It's certainly not a new statement. Does anyone disagree? Do any climate scientists really believe that by doing research on the equilibrium climate sensitivity, as an example, we are contributing to the solution of the climate problem in any direct way? I believe the answer is yes, or at least that we often act, speak, and write as if it were. So we write grants saying why my research is useful for solving the climate change problem, what are the broader perspectives, what are the broader impacts, and so on and so forth. And in general, governments are doing mitigation. Of course, now some private players may get involved in solar radiation management and so on, where science is being created to argue that solar radiation management is safe and we should try it anyway, and so on and so forth, but there is no governance structure, there are no measures to deal with unintended consequences and so on. Whereas adaptation science you can contribute directly to in terms of early warnings, extreme events, heat waves, floods, droughts, etc. And you can also engage stakeholders to see where the gaps are in your creation of climate science knowledge that is working or not working for climate services, climate adaptation, and so on. Remembering again that there are multiple time scales, days to seasons to years to a decade or two, and so on, to do this. More text. Perhaps this studies quantifying the value of climate science using integrated assessment models do not actually represent the views of climate scientists. They are meant, to give governments pathways to think about for the future. Consider then the IPCC itself. On its front web page, the IPCC states that its mission in large bold font is the IPCC was created to provide policymakers with regular scientific assessments on climate change, its implications and potential future risks, as well as to put forward adaptation and mitigation options. And in some smaller type, but still on the front page, IPCC reports are neutral, policy relevant, but not policy prescriptive. What are these statements if not expositions of the linear model where you do science, policy gets, science gets used in policy, decisions come about, and climate action happens? That's the linear models. So we are basically still relying on the linear model that we do science and it just goes into the system to become socially relevant. The policymakers are portrayed as in need of information to make better decisions, and the science itself is neutral, a claim further embodied in the separation between the working groups, with the first focusing on physical science, second on climate impacts, and third on policy responses. Critiques of the IPCC, there are many, have raised the argument that this orientation has diminished IPCC report's practical utility. I happen to agree with that. Perhaps the IPCC could not have formulated its mission differently. It was created to support an international negotiation process with decisions necessarily left to the politicians, and in that it can be argued that it has largely succeeded, even if the negotiations have not. So we haven't bent the curve, but everybody is in the negotiations, and we are working hard to try and meet the demands of the future. But as highly visible, even canonical documents of climate science, and ones which in practice strongly influence the direction of much climate research, IPCC reports define the stance of climate science and climate scientists as much as any single thing does. So IPCC has come to dominate the process from the science side, for good or bad, And IPCC doesn't do climate predictions, even though they are doing decadal predictions now. And somebody has to decide, if the resources being invested in doing 2100 are needed anymore, or have we already given the future what if scenarios that are enough to do what we need to do, and will more science really help in the way IPCC does it? So, mitigation versus adaptation, again by Adam Sobel, but I'm just taking out bits and pieces. Mitigation is a global problem. Carbon dioxide and most other important anthropogenic greenhouse gases are long-lived and well mixed, so that emissions anywhere are the same as emissions anywhere else as far as the atmosphere is concerned, at least carbon dioxide. Causal links between the emissions and the harms they cause are extremely non-local and diffuse compared to those with the other pollution problems. So you can keep on reducing CCUS, but extreme events on India are not necessarily related to local warming, etc. Things are being impacted remotely mostly. The problem can only be adequately addressed by national governments, and the action of smaller units such as individual US states or even individual people are important in the present political context, but will not be adequate unless they lead to larger scale action. Okay, individual actions are important, but they have to scale up to global levels. Plus, when we say usable science, remember what is usable also depends on the political environment, because Trump has become the president now and he may not care about the usability of your climate science, right? My argument here is that there is no productive avenue by which further advances in climate science can be incorporated in a dialogue with those governments so as to influence mitigation policy in a pragmatic way, at least not until the governments, particularly in the USA, but not only there, change very substantially, and perhaps not even then. So mitigation can just focus on solutions, carbon capture, decarbonization, etc. Adaptation, on the other hand, is local. Unlike mitigation, it is different everywhere. There may be commonalities, potential for sharing, learning, and so on, but the nature of climate hazards varies greatly across the planet, as do the ways in which the hazard interacts with the social, economic, political, and cultural factors to generate the risks that adaptation aims to address. The users or the stakeholders need to be national governments. They need not be governments at all. NGOs are often doing this. Thus, they are a much more diverse set of actors than those who have major roles in mitigation, and this diversity creates many more opportunities to do scientific research in support of adaptation, and ultimately that's what is needed. So right now, so our conversation about the urgency and what we do have to really be very synergistic. What to do? If we accept my argument, what are its implications? In particular, how should climate scientists respond? How should a climate scientist respond who wishes to maximize the societal value of their work? Usability is not the only value in science, and I do not wish to argue for a moment that basic climate science research is not a worthy pursuit, even to the extent that it's not usable. For many of us, though, there would be value in a more conscious, examined, and self-critical effort to develop a theory of change that explains the mechanisms by which our research offers value to society. This could take multiple forms. Fundamental understanding is valuable. It would be crazy to argue that we would face the future without robust basic enterprise whose goal is to diagnose, understand, and predict the changes that are occurring to our planet. So process understanding and predictive understanding, even as basic sciences, can still be much more focused than we tend to be right now. Okay, most of my own research career has been spent on what grounds? So it behooves just to jump ahead, in any case, it behooves us to be reflective about the way in which our work engages with the rest of the society or does not. Usability is not the only lens through which to judge this, but it is an important one, especially for climate science, since it considers the most direct form such engagement can take. We might view self-assessment of our work along these lines, individually or collectively, in light of current efforts on diversity, equity, and inclusion in science. And I would say for Indian context or global South context, this is even more critical. With limited resources, limited workforce, we must try harder to focus on societal relevance. The latter efforts apply moral and ethical considerations, etc. There are two sets of concerns. Critical gaze towards what becomes of the knowledge we generate once it leaves our laboratories and the offices. Okay, so moral ethical considerations and the flow of our science beyond our office or campus. These two sets of concerns are not just analogous but intersecting as well, since what science is done is related to who does it and how. There is a value system in which we all do things. Neither set of concerns has historically been more than marginal at best to either the formal education that produces most physical climate scientists or the institutional practices that structure our research, but we might increase our contribution to societal welfare by bringing them both into our work more substantively. So career issues and so on already exist, and actually I have a bit about Deborah Cohen's paper here. I don't know how much more let's just finish it off, okay? So you get the idea what Adam is consternating about, and it's a personal reflection, but it reflects a lot of other people's thought process as well, and I think we really need to worry about these things. Recently, certain members of the scientific community have framed anthropogenic climate change as an invitation to reimagine the practice of science. These calls to reinvent science coalesce around the notion of usable knowledge, signaling the need to ensure that research will serve the needs of those impacted by climate change. But how novel is this concept? A historical analysis reveals that the goal of usability is haunted by Euro-American conceptions of instrumental knowledge dating back to the 19th century. Even as climate research institutions have embraced the radical epistemic ideal of usability over the past 40 years, they have clung to the older definitions of research that are at odds with its anti-individualist implications. Okay, I also have written a lot about the need for teamwork in India especially. So in short, the goal of usability alters the very meaning of research, says Deborah. So I think maybe, this is Deborah. In a world of pure and applied science, research has designated activities along a spectrum from individualistic pursuit of curiosity to the disciplined performance of routine tasks. In the context of usable science, however, research is primarily a form of care. Care for data and its analysis, and care for people and their relationships. I love these lines. When the mark of success is not the approval of experts, but the functionality of the research community, research is about sustaining the interactions that build trust. Making science usable means institutionalizing research as care. Lovely words, right? And these are not going to come from STEM scientists. These have to come from historians, social scientists, anthropologists, and other humanities. Okay, so 33 minutes, not so bad. I read quite fast, but I'm also inserting my own comments and philosophies, because when I do this podcast, which is not pure science, I have to say what I think about it, and I am obviously recording it because I agree with it, but I also have recorded podcasts on whether climate scientists should engage in climate activism, which agrees with my view on not so much, and the other one where somebody provides ways to get over the barriers to your engagement in climate change. So I'm not totally partial to my own view, but of course I'm fond of my own views. Okay, see you in the next topic.